Okay, I just want to talk about shifting. Now, this is your basic shape of your hyperbola and your basic equation. Okay, so there's your basic equation, y equals k over x. The k is just the number on top. Okay, and the number on top will just affect the slope. We'll talk about that soon. So if you're looking at this, we know x can't equal 0, and we know y can't equal 0. And they are the asymptotes of this here. It's the line that it gets closer and closer to, but never actually meets. Now, if you get this equation, and I'm just going to make it, we're going to put it as just 1 on x, and say I shifted it up 3. So to shift it up 3, you would go plus 3. Now, if I shifted it up 3, what that means is that the asymptote will also move up, and it will go up 3 as well. And what will happen here is you'll have this curve here and this curve here, and it has gone up to 3. Okay, so the new asymptote for the y would be y equals 3, and the asymptote for the x would still remain as x equals 0. Because if you look at that, we've got this here, the values of x that it is actually true for would be all of the negative x's, all of the positive x's, but the x that it is not true for would be x equals 0, and that's why x equals 0 is an asymptote. And if you think about it, when you go back to your equation, you can still see if you sub in x equals 0 into that denominator there, like you get y equals 1 over 0 plus 3, you will see that basically x can never equal 0. It will be undefined. Okay, now if you check out your other asymptote, so you go to the y equals 3 one. That's the value of y that it can't ever equal. That is also an asymptote. And I want you to think about this, just have a think about as y approaches, as x gets larger and larger and larger, so as x goes to, say, infinity, and it's getting bigger and bigger and bigger and bigger, you can see that as x is getting bigger, the y value, if you look on that curve, is getting closer and closer to 3. Now I want you to think about that to do with your equation here. So you've got y equals 1 over x plus 3. And as x is getting bigger, let's just say y equals 10. That would be 1 over 10 plus 3. That would be 3 and 1/10. Let's make it bigger. Y equals 1 over 100. That would be 3 and 1/100. And make it bigger again. Y equals 1 over 1,000. That would be 3 and 1,000. So you can see that this part of it here is getting smaller and smaller and smaller. Because as the number on the bottom gets bigger, the whole fraction of 1 over 1,000 is getting smaller. And as this gets smaller, it approaches the number of 3. And you can see here, that's what's happening. The curve is actually approaching 3, which is your asymptote. And the same thing would also happen as x approaches minus infinity. So as x is approaching minus infinity, the same thing would happen. You just get like minus 1 on 10 plus 3, minus 1 on 100 plus 3, minus 1 on 1,000 plus 3. So I hope this gives you a little bit of insight into, like, algebraically that's what's happening, but graphically what's happening is the curve is getting closer and closer to 3, but not actually cutting it. Now, further on that, I'd like you to also look at your domain and range for this function. So the asymptote will affect the domain and range. So the domain for this would be all real x except x equals 0. And if you put that into interval notation, it can't equal minus infinity, so it goes from minus infinity, that's down there, so you can see the curve, so minus infinity, to 0, and then it can't equal 0, so that's why it's a bracket like that, and then it goes 0, and it goes up to infinity. Okay, now if you then look at the range, so the range is going to be all real y, except, now instead of just being y equals 0, it's all of the y, but if you actually look at the curve, it's except y equals 3. So the range here is all real y, except the y value cannot equal 3. So if you put that into interval notation, I'll just get a green, that would be minus infinity, and it will be up to 3, and then it will be 3, and then that would be up to infinity. Okay, now to shift it horizontally, what you would need to do is you need to shift it inside the function. So inside the function would be meaning going x, say x, let's go x minus, and let's put a 2 in there. Because if you think about that, that's like as if you had f of x equals 1 over x, and then if you put in x is x minus 2 into there, you'll get 1 over, and where the x value is, you put x minus 2. So a horizontal shift occurs when it is inside the function. This one here was outside the function, so that's like having y equals f of x plus 3, and the 3 here was outside the function, whereas the 2 here is inside the function. And when it is inside the function, it shifts it the opposite sign. So it'll shift it the opposite sign to the x minus 2, and it'll shift it to x equals 2. That's because of reverse operation when you're solving for the x. So that means that normally your hyperbola will be just inside here and here, but now it's going to shift to the right 2, 1, 2. So that means that your asymptote will be here, and that your hyperbola will go here and here. Okay. So that means your asymptote would be y equals 0, because the y equals 0 is the x-axis, and you can see y can't equal 0, and also x equals 2. Your basic equation is y equals 1 over x minus 2. So if it's x minus 2, it's shifted to the right. If it was x plus 2, it would be shifted to the left. And then your domain. So your domain will be all real x except x equals 2. And if you put into interval notation, it would be minus infinity to 2, and then 2 to infinity. And if you did the range, it'll just be minus infinity to 0 and 0 to infinity. So the range pretty much stays the same.